A chord PQ of a circle is parallel to a tangent drawn at a point R of the circle. Prove that R bisects the arc PRQ. So I need to teach you guys the word chord and the word arc, right? So that is something new over here. Okay, very first thing is the drawing, the diagram. So we need a chord. What is a chord? It's a line joining from one end of the circumference to the other end. Okay, even this is a chord actually. It need not be this short or that long, nothing like that. Diameter is also a chord, right? So to this chord we have a tangent which is parallel to this chord. So this is the basic structure, is it not? Now label the basic things. So this is O, this is PQ, the point of contact is R, this would be XY, and what else? That's it. Okay, so few basic things, we'll have to join all of this by default, right? We tend to, by default we tend to join things and so on and so forth. Okay, let's read the question again. The chord PQ of a circle is parallel to the tangent, right, at point R to the circle. Prove that R bisects the arc. So what is this arc? That we need to understand. So this though is chord, that we understood. Arc is something like this, guys. All of this is your arc. Okay, that's smiley face. It's your arc. You have this arch and all of that, is it not? When you enter a place, welcome to this place, we have arches, right? Temples and cities, and we have arches, a lot of them. So here we are looking at an inverted arch, that's it. So this arch is getting bisected at R. What does it mean? You have to prove that RP is equal to RQ. This length is equal to the other length. This is the whole question. That's it. But how will we do this? First thing is we did few things. We'll mention that. We joined this length, is it not? So we'll mention that. And after that we did the following. We'll call this as M. Without labeling and all of that, we can't move further, is it not? So which color am I looking at? Yeah. Let M be the point of intersection of, it's very important because, well, we'll see. Intersection of PQ and OR. And then we have to prove that R is a midpoint, I guess. No, R bisects. The language is different but means the same. The arc PRQ. Okay, and now the proof. Okay, how is that we are dealing with this? Very first thing is we will tell that this is 90 degree. So every question we are doing that. So let's do this here as well. Angle ORY is 90 degree. The reason, because we have the radius which is perpendicular to the tangent, where at the point of contact okay. Now we have angle OMQ also to be 90 degree. But why? I'm telling angle OMQ is 90 degree because it's equal to ORY. So this are equal to 90 degree. But why is that? How is that possible? It's quite simple actually. We have this two lines to be parallel to each other. This acts like a transversal line. This is your corresponding angles. Does it make sense? Right? So we have, this is because of PQ being parallel to XY. And we have the angles are corresponding angles. Okay, sweet and short. Don't make it too clumsy. That's enough. The language is enough. Now, with all of this information, what should we do? See, the basic funda is in this sheet. Can you think which funda can we use and tell the answer? Okay, it's over here. I hope you guys found it. Equal chords of a circle subtends equal angles at the center. Or equal arcs of a circle subtends equal angles at the center, which can be restated. The converse of this will be the angle subtended by the chord. In place of chord, we can put the word arc. Of a circle at the center are equal, then the arcs are equal. That's it. What we have to tell is, if I prove that these two angles are equal to each other, which they are, you just have to prove them. And because these two angles are equal, so PR is equal to RQ. Because PR is equal to RQ, R has to be the midpoint, that is R bisects the arc PRQ. Okay. So to prove this, we have to prove those two angles are equal. So we'll start off with considering triangles OPM and OMP and triangle OMQ. So we have here angle. No, I'll start off with OM being equal to OM is common. So what are we trying to prove? We are trying to prove the congruency. With congruency, we'll be able to prove the angle, and thus the answer. And we have OP is equal to OQ because both are radius of the same circle. Then we have angle OMQ is equal to angle PMO, both are equal to 90 degree. And so by RHS, not CPCT, sorry, by RHS congruency, we have a triangle OMP to be congruent to triangle OMQ. And now by CPCT, we have angle POM is equal to angle QOM, right? And so we can write the statement that therefore arc PR, see this represents an arc, okay? Instead of writing the word arc, you can just write PR, whatever you guys want, and put a, how do I tell this, a curved line, yeah, curved line, and this is RQ. So why are these two equal? Because of the fact that now we have to write a big line of reasoning, that is as the, as the angles subtended by the arc at the center are equal, right? Thus their lengths are equal. That's it. And with this, what can we tell? This implies R is midpoint, and so R is bisecting the arc PRQ. Hence proved. Okay guys, that's it. So here the star goes to, yeah, we need to give a star, is it not? This point. Without this, you won't be able to understand the question or the answer or anything. Again, it goes back to this. So see to that you take a print and revise.